Section 4.9 is on graphing and solving quadratic inequalities. And our goal in this section is to graph and solve those quadratic inequalities. So we're going to be using inequalities such as greater than or equal to, less than or equal to in two variables. So they can be written in these forms. Now we're going to graph these just like we graphed our inequalities that were linear before, and we're always going to have a shaded area. So our goal is to graph these quadratic inequalities is step one, we're going to graph the parabola just like we did in the past. If it's in vertex form, use the vertex. If it's in intercept form, use the intercept. If it's in standard form, use your negative b over 2a to find the vertex and the axis of symmetry and go from there. Now again, remember, if it's less than or equal to or greater than or equal to, it's going to be a solid line. If it's not, it's going to be dashed line. Pick a test point, see where you shade the correct half plane. So if we look at example 1, we're going to put x equals negative b over 2a. And so b is going to be negative 4, so it's going to be 4 over 2 times negative 1. So this is going to be 4 over negative 2, which is negative 2. So my axis of symmetry is x equals negative 2. So we're going to find the vertex. Well, you plug in negative 2. If you put in negative 2 squared is going to be 4. So that's going to be negative 4. And if you put in negative 2 there, you're going to get plus 8. So it's going to be negative 2, 4. So there's the vertex. We do know it's going to open down. So let's put in a couple more points. If we put in a point at negative 1, that is going to end up giving us 3. If we put in negative 3, that'll give us negative or positive 3. And if we put in 0, we're going to get 0. And at negative 4, we're going to get 0. And this one, since we have just a less than sign, it is a dotted line. And now we have to pick a test point. Well, we have to pick a test point somewhere on our graph. So let's pick just the point 3, 0. So if I plug that in, so the ordered pair that I'm checking is 3, 0. If we put it in, we're going to have 0 is less than or equal to negative 9 minus 12. So 0 is less than negative 21. Is that true? Is 0 less than negative 21? The answer to that is no. Therefore, you shade the opposite side, and that is the inside. My test point was on the outside. It was false, so I shade the inside. So there is my solution. Everything inside of there. Now in example 2, we're going to use a real-life situation. It says a computer desk with a solid glass top can be safely. A computer desk with a solid glass top can safely support a weight of W in pounds, provided that W equals less or is less than or equal to 250 x squared, where x is the thickness. So we're going to start by using this. And since this is a real life situation, we know that when we put numbers in here, it's going to have to be this right side, quadrant 1. Because we can't go negative pounds, we can't go negative thickness of the glass. And so that's what we're going to be putting in. So this is W, and here's the thickness in inches. So we're going to say that this is 1 inch and this is 2 inches. And this is 3 inches. And so we're going to make a table of values. So if I put in 0, I'm going to get 0. Well, that's this point right here. If I put in something where it's 1 inch thick, okay, I'm going to get 250 pounds. It's going to support 250 pounds. If I put in 2 inches, okay, 2 inches is going to be 2 squared is 4. 4 times 250 is 1,000 pounds. All right, so that's quite a jump. Now, if we would graph this, let's say if we're going to go to 1,000 pounds, so let's go by 200, 400, 600, 800, 1,000 pounds. So if we do that, we're going to have 0, 0. We said 1 at 1 inch, we're going to be 250. At 2 inches, we're going to be 1,000 pounds. And it's solid because of the less than or equal to. And we're going to pick a test point. Well, let's pick the test point 1, 0. So again, we put that in. 0 is less than or equal to 250. Is that true? Is 0 less than 250? The answer is yes. So our solution would be everything in here. Okay, so we know that that would be the situation where we could put something on the desk and be confident that it would not break that glass desk. So now when we jump down to example 3, now we're going to be graphing multiple equations or inequalities. And so we're going to take the first one and we're going to graph the first one in blue. And we know that this one has a vertex of 0, -3 because there is no b. It's going to open up. It's going to be a dotted line or a dotted curve. We're going to pick the test point. Well, we can pick 0, 0 here. The other ones it didn't work out to, but this one we can. So it's going to be 0 is greater than -3. Is that true? And yes, 0 is greater than -3, so our shaded area is everything on the inside. The next one we're going to do in red. Hence it's in standard form, so I'm going to go -4 over 2 times -2. So that's going to be 1. So the axis of symmetry here, it's going to be 1. So the vertex is 1. And if we plug that in, we're going to get -2 plus 4 plus 2. So it's going to be 4. And we know it's going to open down. We put in 0, we're going to get 2. And this one is going to be a solid line, or a solid graph. Again, we're going to pick our test point, and we can use 0, 0 here again. So 0 is less than or equal to 2. Is that true? The answer is yes. So everything inside of there is shaded. So our solution is everything inside of where they are both shaded. So I'd like to take a second to go ahead and pause the video, and I want you to graph number 4. So pause the video, graph number 4, and then you can hit play when you are ready. And there's a graph for number 4. Notice they both have axis of symmetry on the y-axis so that x equals 0. The shaded area, or the solution to that system of inequalities, is the red shaded area. The next thing we're going to talk about is graphing inequalities in one variable. And again, they can be written using any of the inequalities that we use. So the first way we're going to do it is solve a quadratic inequality using a table. So we're going to have x squared plus 2x is greater than or equal to 8. So the first thing that we're going to want to do is set it equal to 0. So we know that we're going to have x squared plus 2x minus 8 is greater than or equal to 0. So we're going to go in here, we're going to make our table of values. So we're going to have x, and then we're going to have the x squared plus 2x minus 8. So what our goal is to find the point where this changes. If this y value is bigger than 0, greater than or equal to 0, it means it is above the x-axis. If it is not, if it's less than or equal to 0, that is below the x-axis. So our goal is to find the point where these change directions. So what we need to do is just plug in some points. We don't know where they're going to be. We're just going to start with some points and see if we can find out where it is. So let's put in some numbers, and I'm just going to start, well, I'll start at 0. If I put in 0, I get negative 8. If I put in 1, I get 1. 3, it's going to be negative 5. If I put in 2, I'm going to get 4, that's 8. That's going to be 0. If I put in 3, that's going to give us 9, plus 6 is 15, minus 8, which is 7. If I put in negative 1, we're going to get negative 11. Nope, negative 9. If we put in negative 2, we're going to end up with negative 8. So I need to keep going to the left further. So I need to go negative 3. If we put in negative 3, we're going to get 9 minus 6, which is 3. It's going to give us negative 5. If I put in negative 4, that's going to give me 16, 16, 0. And if I put in negative 5, it's going to give me 25 minus 10, which is 15, minus 8, which is 7. And so now you can see where the pattern happens here. And our goal is to find the place where this is greater than 0. So we want to find out the places where this is greater than or equal to 0, and that is everywhere from here, this direction, and from here, going this direction. So if we're solving using a table, we want to find out where are these values positive, or in this case, equal to 0. And that is going to happen when x is less than or equal to negative 4, and when x is greater than or equal to 2. So as we look for these, this is actually going to be, or it's going to happen either place. It can't happen both of them. But either x has to be less than negative 4 or equal to, or x has to be greater than or equal to 2. So here is the solution for example 4. If we look at example 5, we're going to solve this quadratic equation by graphing the system of equations. Actually, just this one equation. So what we want to do here by graphing it is I want to find the x-intercepts. Well, I know that I can find the x-intercepts using the quadratic formula. Okay, so if we're going to put our numbers in here to the quadratic formula, we're going to get negative 3 plus or minus 3 squared, which is 9, minus 4 times a, which is a half, and c, which is negative 2, over 2 times 1/2. So if we do that, we're going to get negative 3 plus or minus the square root of 9 minus, we're going to have 4 times a half is 2, 2 times negative 2 is 4, so it's going to be 9 plus 4 over 1. So that's going to give us negative 3 plus or minus the square root of 13 over 1. So using our calculators, this will be negative 3 plus or minus approximately 3.61 over 1. So x is going to be negative 3 plus 3.61, which is approximately 0.61. And we're going to have negative 3 minus 3.61, which is negative 6.61. So that tells us that these are our intercepts. The x-intercepts are 0.61, which is approximately right here, and negative 6.61, which is approximately right here. Now, the only other thing that we need to do is find out what this graph's going to look like. And I know that this opens up. So my vertex is down here somewhere. So I know my general graph is going to look like this. And we don't really care what it looks like or how far down that goes. I just want to know where are my solutions if it's an inequality. And here it says it has to be less than 0. So where are my values of y less than 0? And it is between here and here. Okay, so it's in between those because my y values are down here in the negatives. Okay, so my y values are in the negatives between those two x-intercepts. So what we're going to do is write an inequality describing that. And that tells us that negative 6.61 is less than x, which is less than negative 0.61. Okay, and notice here it wasn't less than or equal to, so it's not less than or equal to here, and it has to be in between those two. So this one is an and statement where my y values are negative. We're going to jump down to example 7. It says solve a quadratic inequality algebraically. So first thing we're going to do is try to factor this one. So if I can take out 3, I'm going to get x squared minus 3x minus 4. It's less than or equal to 0. So x minus 4, x plus 1. So I know that my x-intercepts are going to be at 4 and negative 1. So if we have that, we know that they are at 4 and negative 1. So negative 4, 1, 4. So negative 2, negative 1, 0, 1, 2, 3, 4. All right, so we want to find out where our values, positive, negative. And once again, we know that this graph, if we were going to do this algebraically, we know that here are my intercepts. All right, negative 1 and at 4. That's the point where they change directions. So is our solution going to be in between those, or is it going to be outside of those? And so all you have to do is pick a test point. So I'm going to pick 0. Okay, if we put in 0, well, if we do that into the original equation, I'm going to get 0 is less than, or negative 12 is less than 0. Is that a true statement? Is negative 12 less than 0? The answer is yes. So therefore, I know my solutions must be in between there. So therefore, -1 is less than x, which is less than 4, and there is your answer. If that would have been a false solution, then we'd have to try the points on the outsides to see if it was true, and then they would be the solution. So if it was outside of those, it would be an OR statement. So your assignment is on page 304.